Greetings everyone and welcome to the 7th video in this 10 video series. My name is Vyom Khanna and I am thrilled to be with you all today. In the previous video, I hope you learned a great deal about temperature, humidity and ultrasonic sensors and how you can use them in your projects. Over the remaining videos, we will delve deep into concepts like Node MCU, robots, soldering, and most importantly, the real-life applications. Today, we are on the 7th video in this series, so let's keep on going. This video will explore LCD panels and other cool components along with how we can integrate them into our projects so that we can achieve more. LCD panels fulfill a major function and are completely unique in terms of their application. They can add great utility to our projects by physically displaying anything we want, provided we have set them up and coded them correctly. So let's get right in and explore all there is to know about LCDs. The LCD, full form liquid crystal display, is a flat panel display which uses liquid crystals in its primary form of operation. LCDs have a large and varying set of use cases for consumers and businesses, and they can be commonly found in smartphones, televisions, computer monitors, and instrument panels. LCDs were a huge leap in terms of the technology that they replaced, which include light-emitting diodes, or LEDs, and gas plasma displays. LCDs allowed displays to be much thinner than cathode ray tube technology. They also consume much less power than an LED and gas displays because they work on the principle of blocking light rather than emitting it. While an LED emits light, the liquid crystals in an LCD produce an image using a backlight which works by blocking incoming rays. As LCDs have replaced older display technologies, they themselves have begun being replaced by new display technologies like OLEDs. An LCD display is made up of millions of pixels. The quality of a display commonly refers to the number of pixels. For example, a 4K display is made up of 3840 by 2160 pixels. In turn, a pixel is made up of 3 subpixels, red, blue, and green, commonly called RGB. When the subpixels in a pixel change the color combinations, different colors can be produced. With all the pixels on a display working together, a display can make millions of different colors. When the pixels are rapidly switched on and off, a moving picture can even be created. The way a pixel is controlled is different in each type of display, namely CRT, LED, and LCD. What's fascinating is that all these newer types of displays control pixels in completely different ways. Summarizing all the information into simple and concise sentences, LCDs are lit by a backlight and pixels are switched on and off electronically while using liquid crystals to rotate polarized light. A polarizing glass filter is placed in front and behind all the pixels. In between both the filters are liquid crystals, which can electronically be switched on or off. That's all about the anatomy and concept part of an LCD. Now, let's look at what they mean in the world of Arduino. An LCD character display is a unique type of display that can only output individual ASCII characters with a fixed size. Using these individual characters, we can make all the sentences we can think of. That's all the technical information you need to know about LCDs. So let's get right into how you can use them with the Arduino UNO. The LCD that you will be using has a total of 16 pins, and the first one from the left to the right is the ground pin. The second one is the VCC, which we connect to the 5 volts pin on the Arduino board. Next is the V0 pin, on which we can attach a potentiometer for controlling the contrast of the display. Don't worry if you don't understand what a potentiometer is, it will be explained as the video progresses. Next, the RS pin or register select pin is used for selecting whether we will send commands or data to the LCD. For example, if the RS pin is set to a low state or 0 volts, then we are sending commands to the LCD, like setting the cursor to a specific location, clearing the display, turning off the display, and so on. Along with that, when the RS pin is set on a high state or 5 volts, we are sending data or characters to the LCD. Next comes the RW pin, which selects the mode that decides whether we will read or write to the LCD. That is why the RW stands for read or write. Here, the write mode is obvious and it is used for writing or sending commands and data to the LCD. The read mode is used by the LCD itself when executing the program, which we don't need to discuss in this tutorial. For now, let's just focus briefly on what each pin does.
Next is the E pin, which initiates the writing process to the registers, or the next 8 data pins from D0 to D7. Basically, through this pin, we are sending the 8 bits of data when we are writing to the other pins on the LCD board. For example, if we want to see the letter uppercase A on the display, we will send 0100 001 to the registers according to the ASCII table. The last 2 pins, A and K, or anode and cathode, are for the LED backlight. This much information is more than sufficient for the current time being. After all, we don't have to worry much about how the LCD works, as the liquid crystal library available on the Arduino IDE takes care of almost everything. From Arduino's official website, you can find and see the functions of the library which enable easy use of the LCD. We can use the library in 4 or 8-bit mode. In this tutorial, we will be using it in 4-bit mode. In short, we will just use 8 of the 4 data pins. Lastly, let us also learn about the potentiometer, which is an essential component used to adjust the brightness of the LCDs. A potentiometer is a single mechanical device that provides a varying amount of resistance when its shaft is turned. By passing a voltage through a potentiometer and into an analog input on the Arduino UNO, it is possible to measure the amount of resistance produced by a potentiometer as an analog value. That was a whole lot of information, but don't worry, you do not need to know all of it. Most importantly though, you need to know what each pin on the LCD represents. Now, let's look at the circuit diagram. Here's how you need to connect the 16:2 LCD display to an Arduino board. Firstly, you need to solder your LCD to the pins, which can be done at a nearby electronics shop. Only after you've done that can you proceed. Look at the diagram on the screen carefully, as you need to refer to it when wiring your circuit. Notice the labeling on both the boards, as you do not want to get anything wrong. It will be almost impossible to notice later. We will use just 6 digital input pins from the Arduino board. The LCD registers from D4 to D7 will be connected to Arduino's digital pins from 4 to 7. The enable pin will be connected to pin number 2, and the RS pin will be connected to pin number 1. The read or write pin will be connected to the ground, and the V0 pin will be connected to the potentiometer's middle pin. Note the connections on the potentiometer as well, and for the remaining pins, including the power connections, consult this diagram. That's all you need. One other important thing to know is how to adjust the contrast and brightness of your LCD. You will need to do this using the previously mentioned potentiometer. We can adjust the contrast of the LCD by adjusting the voltage input at the V0 pin. We are using a potentiometer because it enables us to easily fine-tune the contrast by adjusting the input voltage from 0 to 5 volts. All you need to do is simply turn the shaft on the potentiometer until you reach a brightness on the LCD that you are satisfied with. Don't start turning the dial right now, as you need to wait for the code to be uploaded. You may ask if you can use the LCD without a potentiometer. Well, in case you don't have a potentiometer, it is possible. You can still adjust the LCD contrast by using a voltage divider made out of two resistors. Using the voltage divider, we need to set the voltage value between 0 and 5 volts in order to get a good contrast on the display. But this is not the recommended approach and is certainly more complicated than using a potentiometer. So, I would not advise you to adopt it. The potentiometer is all you need to control resistance. Now that all the remaining work is done, we can finally move on to the coding aspect. So let's get right into it.
Here's a simple code through which we can explain the working principle of the liquid crystal library. Obviously, you want to download the liquid crystal library first. So do that before you get coding started. We can do it like this. First click the sketch button, then include library, and then type in liquid crystal. That's it. Now we can start the real coding. Now we have to create a liquid crystal object. The parameters of this object should be the numbers of the digital input pins of the Arduino board respectively to the LCD's pins as follows: RS, enable, D4, D5, D6 and D7. In the setup, we have to initialize the interface to the LCD and specify the dimensions of the display using the begin function. In the loop, we write our main program. Using the print function, we print on the LCD. The setCursor function is used for setting the location at which the subsequent text written to the LCD will be displayed. The blink function is used for displaying a blinking cursor, and the noBlink function for turning off the cursor. Also, the cursor function is used to display an underscore cursor, and the noCursor function is to turn it off. Using the clear function, we can clear the LCD screen. The above code is simply there to educate you about the liquid crystal library and its various functions. Hopefully, you understood what it all meant and are ready to write your own code. As a reference, here is a program in which you can write a sentence and display it on an LCD. I'll leave it on for 5 seconds. Do take note of all the functions used and try to think about what you will utilize them for in the future. That's all for today. You learned a lot, so give yourself a pat on the back. Until we meet next time, bye.